Nomenclature of ketones. Ketones can be classified under two different heads. The symmetrical ketones are going to have exactly the same R on both sides of the carbonyl group. The unsymmetrical ketones are going to have different R's. Let's take the first example. The simplest ketone that you can have is propanone, which has 3 carbons. This is the simplest ketone you can have. If you change one of this to be an hydrogen, then it's not going to be a ketone. Instead, it's going to be an aldehyde. So the simplest ketone that you can have is propanone. Now for the second compound, you have to give the numbering for this compound. You have to consider this as your functional group. So this is your carbonyl functional group. This is your ketone functional group because it is attached to 2 carbons. And you have to make sure that this carbonyl group gets the lowest possible number after you find the longest chain, making sure that the carbonyl group is included in the longest chain, right? So here there is only one chain, right? And you have to number this compound from left to right so as to give the carbonyl group the lowest possible number. So this would be the numbering for this compound. And since there are 6 carbons, it's going to be hexanone because the ketones need to end with -one, right? That would be the suffix for the ketones. And you also needed to give the position for this carbonyl group because this carbonyl group can also exist here. So in which case it's going to be 2-hexanone. But because this carbonyl group is on the 3rd carbon, or the carbonyl group is at the 3rd position, this is called as 3-hexanone. That would be the complete name for this molecule. Let's take a look into the next compound. So in the next compound, again, you need to make sure that you find the longest chain, making sure to put the carbonyl group within the longest chain, and also give the lowest possible number for this functional group. So you cannot number in this direction because that way this is going to have a higher number. So you have to go from right to left for this molecule. 1, 2, 3, 4, 5, 6, and either of these carbons can be 7, right? So since it has got totally 7 carbons, it would be heptanone, and the carbonyl group is present in the 2nd position. So this would be 2-heptanone, and when you say 2-heptanone, it's going to apply only to this part, but there is a methyl group that is attached to the 6th position. So this would be called as 6-methyl 2-heptanone. Let's also do the common names for these molecules. So this one right here is called as acetone. That would be the brand name for this molecule as well, acetone. But they can also have derived name. When you say derived name, you're going to name this more like how you name the ethers, right? So you have 2 methyls, therefore this is going to be dimethyl, and the functional group is a ketone, so you're going to simply call this as dimethyl ketone. And for this compound, similarly, you do have an ethyl group here and a propyl group here. So this is an ethyl group and this is a propyl group. And you can list the ethyl in the front because E comes first in the alphabet and then comes P. So ethyl propyl ketone. And for this compound right here, you do have a methyl group and you also have an isohexyl group. So this group right here, is an iso group, right? And you do have 6 carbons, right? So 1, 2, 3, 4, 5, 6 carbons. So this would be isohexyl methyl ketone. When you have the carbonyl group coming off of the ring structure, then you're going to simply write the name of the ring structure followed by "-one", right? So for example, here you have a cyclohexane ring structure, and on it you have the carbonyl group, right? Like this carbon, which is part of the cyclohexane ring, is where your carbonyl group is present. So in which case you're going to call this cyclohexanone. This is the IUPAC name, cyclohexanone. When you have two carbonyl groups, which is part of the ketones, then it's going to be called as dione. Say, for example, when you have two aldehydes, you're going to call this as diol, right? So for two aldehydes. When you have two ketones, you're going to call this as dione because there are two ones here. So here you have two ketones, right? Two ketone group, and you're going to find out how many carbons are present in the longest chain. So there are totally 4 carbons, and therefore this should have the prefix of butane, and then the suffix is going to be dione. Let's go on to the next one. Here also we do have two carbonyl groups, right? Let's find the number of carbons in the longest chain. So we have totally 5 carbons. So this is going to be pentane dione. When you say pentane dione, it could mean two things. Say, for example, you can also have the carbonyl group here and the CH2 group here. So this is also pentane dione. But if you want to give a more specific name for this compound, this should be 2,4 pentane dione because you have to give the numbering for this. So 1, 2, 3, 4, 5. And you can also a number in the other direction because this molecule is symmetric, right? So you can also give in the other direction. Right, so that is going to specify this molecule. So if we say 2,4-pentane dione, this is only going to specify this molecule. Let's now do the IUPAC name for the next compound. For the next compound, yes, of course, this is a ketone because you do have two carbons attached to the carbonyl group. And here again, you need to make sure that the carbonyl group gets the lowest possible number. So this carbon would be number 1, 2, 3, 4, 5, 6. So there are 6 carbons in this chain, and also you do have a double bond. So this shouldn't be called as hexanone. Instead, it should be called as hexenone, right? It should be called as hexenone. Now we needed to make sure that we also give the position for the carbonyl group. The carbonyl group is at position 2, so therefore it should be written as hexene 2-one, and you needed to give the position for the double bond. The double bond is existing at position 4, right? So it should be 4-hexene 2-one. That would be the proper name for this molecule. Let's now name some ketones where there is an additional functional group which has higher priority than the ketone itself. Here we have an aldehyde and also a ketone. Now let's take a look at the priority charts to find out where the ketones and aldehydes are. So ketone is right here and aldehyde is right here. So which means aldehyde is going to have higher priority, and therefore the ketone should be named with the prefix of oxo, and the aldehyde should be named with the suffix of al. Okay, so this carbon right here would be number 1, and the oxo group is at number 4. Now, because we do have 5 carbons here in this longest chain, this is called as pentanal since aldehyde has higher priority than ketone. So pentanal would be the parent name, and we also have a 4-oxo group on this pentanal. So this would be the name for this molecule. Let's take a look into the next compound. We do have an ester group and also a ketone. And obviously when you take a look into this, the ketone is here and the ester is here, which means this is going to have higher priority. And the high priority group should have the suffix, whereas the low priority group should have the prefix. Now let's give the numbering. So this carbon would be number 1, this is 2, and 3, 4. There are 4 carbons in this compound, and therefore this should be butanoate since this is an ester. And this is a methyl ester, so we can put the methyl in the front, in the very front, and any substitution that isn't present in the ester itself will be in between. Now you do have an oxo group in the 3rd position, so this would be methyl 3-oxobutanoate. That would be the name for this molecule. Let's now do the IUPAC name for this molecule. Here we do have an amide, so this part right here is an amide. This is an amide functional group and also a ketone. And between an amide and ketone, obviously, the amide is going to have higher priority. So this would be the suffix and the ketone would again be the prefix. So this carbon would be number 1, 3, 4, 5, 6. There are 6 carbons. So, and this is an amide, and therefore this would be hexanamide. And on hexanamide is present a ketone, and this is at the 5th position, and the ketone should be represented as an oxo, as a prefix. Here are some ketones where the carbonyl group is directly attached to the benzene structure. Now first we are going to find the acyl group. This is an acyl group, right? So this particular acyl group is called as acetyl group. The benzene ring is going to be called as phenyl group, but this phenyl group is attached to a carbonyl group, and therefore this is going to be called as phenone. So we have phenone, and we also have an acetyl group, and this acetyl group should now be called as aceto, and we are going to put that in the front of phenone. So this molecule has the name acetophenone. Now let's do the same thing to find the name for the next compound. So this compound, again, we are going to find the acyl group here. This is our acyl group. We have 1, 2, 3, 4 carbons, and therefore this is going to be butyrol, right? And in the same way, and again, we do have a phenyl group that is attached to the carbonyl group, and therefore this should be phenone. So this would be butyrophenone. Let's identify what's the name for this molecule. Now this part right here is a benzo group. Why? Because when we were talking about the acid chlorides, we said that this molecule right here is benzoyl chloride. So in the same way, for this molecule, for this part of the molecule, we are going to call this benzo. And again, we do have a phenone group, right? Because we do have a phenyl group that is directly connected to the carbonyl group. So this molecule would be called as benzophenone. Now, when we want to find the derived names, obviously we're going to find the 2 substituents that are connected to the carbonyl group. So this one right here is a phenyl group, and this one right here is a methyl. So we're going to put it in alphabetical order, and this would be methyl phenyl ketone. And for the next one, we do have a propyl group here, and we do have a phenyl group. So this would be phenyl propyl ketone. The first letter P is a tie in both of these, and we have to focus on the next letter. So H comes first, and therefore it's going to be phenylpropyl ketone. And for the next compound, there are 2 phenyl groups, and therefore you're going to call this as diphenyl ketone.